The last part of Unit 3 is a lever system from Chapter 10. Our muscle moves bones around a joint with a mechanism of a lever system. A lever system always contains a rigid bar, which we call it a lever, and this lever will move around a fixed point, like a pair of scissors and the bottom opener. Those are a lever system. The rigid bar, we call it a lever, and the fixed point, we call it a fulcrum. In our body, it's the joint, and the rigid bar in our body, that is a bone. So the force that moves the lever around is an effort, which moves the lever. And there's a resistance, which is a load. We call it a load. So the resistance and effort work together to move the lever system, to move the lever. So in this class, it is very important to identify the 3 points of fulcrum and where the effort is and where the load is. As in this picture here, you see this is a point of fulcrum, here is a point of effort, and here is a load. So you are looking for the 3 points on the lever, on the rigid bar. In our body, when one muscle contracts, the lever is our bone and the fixed point is our joint. Take the flexion of the elbow as an example, as is showing in this picture here. The fulcrum here is the joint, which is a fulcrum. And the effort comes from the contraction of our biceps. So this is muscle. And the lever should be the forearm. So that is a bar. And the muscle will pull on the forearm here. So that is an effort. That is a point of the effort. And also the load is a gravity of the forearm and hand, so that is somewhere normally in the middle. And if the hand holds some weight there, that will be the load as well. Okay, so in this picture, you find those fulcrum and also effort and the load. You know the location where they are. Okay, so here is a very simple lever system. So when the bicep contracts a little, what happens is the whole lever will move up just to a new condition, new location here. And you see this muscle pull it up, and the hand will move for a bigger distance like this. Okay, so the hand is pulled up around the fulcrum hinge. Okay, it's a hinge joint. In physics, the law of a lever is that the effort times the length of the effort arm is equal to the load times the length of the load arm. Okay, in fact, what you see is the load here, the weight of the M1 times the distance. Change the color here. Change this distance equal to this weight times this distance. Okay. Well, here is a physiology class, and I will not ask you to calculate, but you need to get the idea that you can save some effort by increase the distance between the fulcrum and the effort point, and vice versa. So if the B get increased, then you can use a less M2 to maintain what happened here. Okay, so you can save some effort or increase the output distance by just changing the distance, the length of the lever. With the lever's law in mind, now you see why we are able to lift a 1-ton car with a jack. You may need to put the effort, which is only 1/1000th of the car weight, to lift the car. But the cost is that to move your car 1 inch up, your hand have to move 1,000 inches in distance. So you just use the distance as a cost to use a less effort, less force to move things around. Okay, so this type of lever save a lot of effort, so we call it a mechanical advantage. That's the name, mechanical advantage, because it saves effort, and also because the output is a lot of power, a lot of strength from the output, so we also call it power lever, because it increases the power. It happens when the load fulcrum distance is smaller than the effort fulcrum distance. On the other hand, if the load fulcrum distance is larger than the effort fulcrum distance, then you can give effort to move the load further and faster, but the cost will be you have to put more effort than the load itself. And in this picture here, the lever is the shovel, and the right hand is the fixed point, the fulcrum, and the left hand gives the effort because he will use the left hand to lift up the shovel here. So what happened is, once his left hand move the shovel up, so that is a distance his hand will go through. And at the same time, the load on the shovel will raise up on a farther distance and also faster compared to the hand. In this kind of lever, the person have to move bigger effort than the load itself. It do not save any energy, do not save any effort, but the good thing is you move things faster and also further. Okay, so we call this type of lever is a mechanical disadvantage, and it's a speed lever since it output more speed rather than to save some effort. So the levers are either mechanical advantage or mechanical disadvantage. The advantage one save effort, and the disadvantage one use more effort, but at the same time you will get more speed on the load itself. In our body, all the movable joints are example of a lever system. For example, the TMJ here in the picture. The lever for the left picture here, the lever here is a mandible. Just put a bar here, and the joint is always the fixed point, that's a fulcrum. And the load is normally the weight of the muscle and also the weight of the bone, that's the mandible weight. And sometimes if you are biting something, so those food will be the load as well. And the muscle give you the effort. It's a pulling at that point, and that is effort. Okay, so here you see the 3 points, 3 components of the lever are all here: fulcrum, effort, and the load. So that is a lever system, and you can see that in this lever system is a mechanical disadvantage. You just move the muscle a little bit and you will move the mandible in a bigger distance. And on the right side of the picture here, you can see it's very similar. It's a lever here, and the fulcrum is here. So the same, the load is a weight and everything. The foot between the teeth, and the effort comes from the masseters here, but kind of the same point. It's a ramus here, but that is an effort. Okay, so both of those 2 muscles function about the same to move in a small distance, to move the mandible in a bigger distance. By the effort and the load distance to the fulcrum, we can classify the levers into mechanical advantage or disadvantage. And as we just discussed in previous slides, so the efforts further than the load from the fulcrum is always an advantage. That one just save effort, and on the other hand, if the effort is more close to the fulcrum, and that's a disadvantage. So just think, do you use more effort to move a small thing, get more distance, get more speed, or you get more power. So those are the classification by the distance. And there's another way to classify the lever systems. We can classify the levers into 3 classes by the relative position of the effort. So it depends on the effort, fulcrum, and location and load location positions. Okay, so that is why it is very important to identify those 3 points in a given lever, because you need to recognize the lever type with a given example. The names of the 3 types are very simple: first, second, and third class lever. And as long as you are able to identify where is a fulcrum is, where the load is, and where is the effort, the classification is very easy to recognize as well. So for the first class lever, it's a fulcrum located as a in the middle between the load and effort. Okay, fulcrum is between the other 2. And the example is like a scissors, seesaw, so the fulcrum is always between the load and effort. In our body, take the atlanto-occipital joint as an example. So the fulcrum is here, is a atlanto-occipital between the C1 and the skull. Here is a fulcrum at this location here. And the bar, look for the lever, it's more like somewhere here, just imagine there's a bar here, but in fact the whole school is a lever here. So the load will be the weight of the head, so that's at this point, so that is load, and here is F. And the effort will be the muscle that connect the skull to move it up, and here, remember the name of the muscle here, sternocleidomastoid, because it connect to the mastoid. So the mastoid, that part is the effort. So you see the F fulcrum is in the middle. That is a first class lever. Okay, so it's very important to recognize where the fulcrum is, where the load is, and where is the effort. So the one in the middle tell you which class lever it is. The second class lever have the load in the middle. The load, if the load is between the fulcrum and effort, those are the second class lever. Like the wheelbarrow and when you're standing on toes, those load are in the middle. Examples in the body is standing on the toe. So the fulcrum, here is our lever. See the lever here, that's a bar. And the F at this location, the fulcrum, which is a fixed point. And the load is a whole body weight. The whole body weight is normally, just think about the location here. So that is load, which is the L, load. And the effort will be the muscle. The muscle that connect to the tendon, so it's on the heel. So that is the effort. So look for the middle letter. The middle thing is the load, which is second class lever. And the third class lever have the effort in the middle. We just have the left. So if the effort is in the middle, then we call it a third class lever. Like when someone is using the shovel, like in the picture there, we just show there, the shovel using, the effort is in the middle, so that's a third class lever. And if someone is using the tweezer like this, the effort is in the middle, so that is a third class lever. Okay. And we also learned there's a speed lever and a power lever. That's another way to classify the lever. Speed lever, what you need is a speed, is a movement, and that is a mechanical disadvantage, and the power level, what you want is a strength. You want the output is a strength, so you just use more work longer or further to get those distance to get the strength. Okay, that's a power lever. So those are the two different ways to classify our lever system, either by the output in the strength or speed, or either by the location of the three things: the effort, fulcrum, and load. What is the location of those three different positions of them? Okay. Here is one more example of those classification of the lever. So you can see here the lever, for where the lever is the forearm, and the fixed point is the elbow. That's F. And the bicep point to this location here, that's E. And the load is at the end if you're just have the weight at that location. So the E is at the center, is in the middle of load and fulcrum, and that's a third class lever. Okay, in fact, it's very easy to remember those first, second, and third class lever if you just remember this. Okay, here is my trick to remember those. Flex. Okay, so flex is a trick to remember which class of lever it is. If the middle point, the middle thing is fulcrum, that is a first class. Okay, if the fulcrum is between the load and effort, that is first. Okay, and if the load are in the middle, that's a second. And if the effort is in the middle, that is a third. Easy, right? If you don't like X, just say fly. Alright, so those are the three different type of lever, and you can just distinguish which class it is by look for the middle thing, which one is in the middle to determine is the first, second, or third class lever. Here is our review question. Look at this picture and tell me which class of lever system it is. Just use the first, second, and third. Which one is it? So again, let's see. Here's a lever, and this is a load because the weight are there. Those are the resistance, and the thing, the food you are eating in your mouth, those are the load. And the fulcrum is a joint, F. In the muscle pull at the location, that is an effort because you are putting some effort on it. It's active, so that is effort. So which one is in the middle? In the middle, that's effort, right? Effort. So again, use a flex, or if you like a flay. So flex, the E in the middle, E, and count it. 1, 2, 3. It's the third letter of the flex. So it's a third class of a lever. Did you get that? Okay. Alright, so that's a E, third letter, third class of lever. Simple, isn't it? So that is a three class of the lever system, but if you divide the lever into a speed or power lever, what you need to think is, did you get more speed or did you get more power? So the same example, if you just think about the TMG in the previous picture, what you get is a more power or more speed. It should be a speed lever because the muscle move a small distance, but your teeth, especially the incisors, they just have a big distance, and that's you get a big speed. Let's see the review question here. Bones and muscles work together to move your body. In this case, one bone is what, and the other bone is the answer should be D. One is a lever because it's rigid bar, and the other is a weight, is the load. Think about the elbow flexion, so the humerus, that is lever, and the forearm, in fact, the radius and ulna together with the muscle there. Those are the load. Next one. In which class of levers is the load between the fulcrum and the effort? The answer is a second class. Remember, when we see flex, the load is between the fulcrum and the effort. So look for the L. The L is a second, 1, 2, and that is second. Second letter means the load between the fulcrum and the effort. That is a second class. Okay, so the flex word itself is just just a trick. You remember first, second, and third lever. Okay, the last question. Flexing the forearm with the biceps brachii is an example of which class of a lever system? The answer is C. Did you get it? So just get a scratch paper and let's see the flexing of the forearm. So here is the upper limb. Well, consider this as a hand, okay? So the forearm with a bicep brachii, which is this location here. You pull the forearm and the lever is this location. F is a joint, biceps is an effort, and the load, let's see the hand. So E is at the middle, and the E is a third letter of the flex, so this is a third class of lever. Did you get that? It's not so bad, right? Alright, so that's all you need to know about the chapter 10 for the lecture. The rest of the chapter 10 are the information that you need to know for the lab part. Okay, enjoy!